So hi, in today's lecture, we are going to find a middle node in the linked list. Okay, so they will be giving us a linked list in which by passing the head, now we need to return the middle node. Okay, in a sense, we need to return the address of that middle node. Okay, so over here, if we take a look on this linked list, okay, the length of this node is 5. Okay, so obviously the middle element will be this, right? But what if the length of the node is even? Okay, so here we can say there are 6 nodes. Okay, so the middle nodes are 2, which is this. Okay, so if that's the case, then we need to return the second node of the middle 2 nodes. Okay, so this is the question. I hope you got this. Now what will be the first approach to solve this problem? See, what you can do first, you can traverse in the whole array. Okay, just to find the length of the linked list. Okay, why? Because here in both the scenarios we have to do different operation for even and odd. Okay, so the first step would be traverse in whole linked list to find the length, that is n. Okay, after finding the length, okay, if n is odd, so let's take if n is 5. Okay, so we will be finding middle, that is 5 by 2, that will be 2, right? So we have to return the third node, right? So why? Because 5 by 2 is 2.5, so we need to take the seal value, so which will be 3. So we have to traverse it again, okay, till 2 plus 1. Okay, now if n is even, so let's say n is 6. Okay, so again we will be finding the middle, so 6 by 2, that will be 3. So here also we can see that we have to uh, return the second node, right, of the middle. So we have to traverse again till 3 plus 1 time. Okay, so this is it. After traversing, you can just return that node address of the node. Okay, so if we talk about this over here, we are traversing for n time, okay, to find the length, and either the n can be odd or n can be even. Okay, so we will be not traversing 2 times. Okay, either it can be odd or it can be even, so we will be traversing only 1 time. So this will be basically n by 2 only. Okay, but we have to take n, so it will be 2n, so the time complexity for this will be order of n. Okay, and we didn't take any extra space, so the space complexity will be order of 1. Okay, so this is one of the approach. Now the other approach is very interesting. Okay, see, so here is the idea. Okay, now just imagine that this is a racetrack. Okay, the the length of this racetrack is 1 kilometer. Okay, and we have two candidate, one is tortoise and one is a rabbit. Okay, now see, rabbit has a speed of 1 kilometer per hour. Okay, and tortoise has a speed of 0.5 kilometer per hour. Okay, so think about it. If this is a 1 kilometer racetrack, okay, and if the rabbit is touching at the finish line, okay, over here, so obviously tortoise will be in the middle. Why? Because he has a half of the speed of the rabbit, right? So with this analogy only, if I have a linked list, okay, and here I will be having 2 pointers, let's say p1 and p2. Okay, p1 takes the jump of 2 at a time, so while traversing he will be taking a jump 2 times, but p2 takes the jump of only 1 time. Okay, So since the P1 takes jump of 2 time, okay, 2 at a time, okay. So when P1 is at the last node, okay, obviously P2 will be at the middle, right? So with this analogy only, we will be finding the middle node, okay. So here I will be renaming this pointer. So this one will be the fast pointer and this will be the slow pointer, okay. So let's do this. So for the first time, fast pointer takes the jump of 2, whereas slow pointer takes the jump of 1, okay. This is the first iteration. Now again, fast pointer takes the jump of 2 and the slow pointer takes the jump of 1, okay. So by the end, when fast pointer is at the last node, slow pointer will be at the middle, okay. Let's take one more example in the even length. This is a fast pointer, this is a slow pointer, okay. So see, first fast pointer will move 2 step and slow pointer will move 1 step. Again, fast pointer will move 2 step and slow pointer will move 1 step. Now fast pointer will move 2 step, okay, but slow pointer will move 1 step, okay. So here we have to take a look that fast pointer can be either at the last node or at the null, okay. So if the fast pointer is at last node or it is at null, we have to stop, okay, and we have to return the address of the slow pointer, so we can see that the slow pointer is at the middle, okay. So with this analogy, we are going to solve this problem. So initially, there will be a fast pointer whose initial value is head, and there will be a slow pointer also initial value is head, okay. Now we will be having a while loop. Now the condition we have taken a look that the fast pointer can be either at the last node or it can be on the null, okay. So fast pointer, if it is not equals to null and fast pointer dot next is not equals to null, okay. See guys, this is for this one, okay, and this is for this one, okay. Now if both the condition are true, then I will be jumping fast pointer 2 times, okay. So fast pointer will be fast pointer dot next, okay, and slow pointer is equals to slow pointer dot next. That's it, and we are done. So at the last, we need to return just this slow pointer. Okay, I know that. See, this approach is also taking order of n time, okay, but we don't have to traverse it for the 2 time, okay, and this is a pretty interesting and different approach, okay. So the time complexity for this will be order of n, and since we didn't take any extra space, so the space complexity will be order of 1, okay. I will be sharing both of the code in the description so you can take a look. So that's it from my side. I'll see you in the next lecture. Till then, keep practicing.